Hi everyone. So today, let's go to do a walk through on performing the ETL on a dataset using AWS Glue. So here's a lab overview and objectives. Big data problems often involve a large number of heterogeneous data sources. As a data analyst, you might not know the schema for some data sources. This is the variety aspect of the 5 V's of big data: volume, variety, velocity, veracity, and value. In this lab, you will work with AWS Glue to perform extract, transform, and load ETL for a dataset. You can direct AWS Glue to a data source and it can infer a schema based on the data type that is discovered. Then AWS Glue built a data catalog that contains metadata about the various data sources. AWS Glue is similar to Amazon Athena in that the actual data that you analyze remains in the data source. The key difference is that you can build a crawler with AWS Glue to discover the schema and then extract the data from the dataset. You can also transform the schema and then load the data into the AWS Glue database. You can then analyze the data by using SQL statement in Athena. In this lab, you will learn how to use AWS Glue to import a dataset from Amazon Simple Storage Service Amazon S3. You will then extract the data, transform its schema, and load the dataset into a AWS Glue database for later analysis by using Athena. After completing this lab, you will be able to do the following: access AWS Glue in the AWS Management Console and create a crawler. Create a AWS Glue database with tables and a schema by using a crawler. Query data in the AWS Glue database by using Athena. Create and deploy AWS Glue crawler by using an AWS CloudFormation template. Review an AWS identity and access management IAM policies for users to run an AWS Glue crawler and query an AWS Glue database in Athena. Confirm that a user with IAM policies can use the AWS command line interface AWS CLI to access the AWS Glue database that the crawler created. Confirm that a user can run the AWS Glue crawler when the source data changes. Okay, so here let's go to the scenario. The data science team has asked you to create a series of proofs of concept POCs to use AWS services to address many of the data engineering and data analysis needs of the university. One of the data science team members has seen that Athena can do what Athena can do to create tables that have defined schemas and is impressed. She asks you if it's possible to infer the column and data types automatically. Defining the schema takes much of her time when she deals with large amounts of varied data. You want to develop a POC to use AWS Glue, which is designed for use cases that are similar to this one. To develop a POC, Mary suggests that you use a publicly available dataset. The Global Historical Climatologies Network Daily GHCND dataset contains daily weather summaries from ground-based stations. Going back to 1763, the dataset is publicly available in an S3 bucket. Mary explains that the most common recorded parameters in the datasets are daily temperatures, rainfall, and snowfall. These parameters are useful to assess risk for drought, flooding, and extreme weather. The data definitions used in this lab are available on the NOAA Global Historical Climatologies Network Daily GHCND datasets page. Note, as of October 2022, the datasets has been split into sub-dataset by year and by station. Throughout this lab, you will be using by year, and it can be found here at this link. So when you start the lab, the environment will contain the resources that are shown in the following diagram. So for this lab environment, the original data source is an S2 bucket that exists in another AWS account. So here, what we started at. We have AWS account. There's IAM with the policies and a Glue lab IAM role. Um, Here are two different buckets, and here is another AWS account with another bucket filled with the dataset. So the lab environment is created with the CloudFormation template that is deployed when you launch the lab. The resulting CloudFormation stack creates two S3 buckets entitled Data Science Bucket and Glue 1950 Bucket, an IAM Policies entitled Policies for Data Scientists, and an IAM Road entitled Glue Lab. To review the CloudFormation template that built this environment, navigate to the CloudFormation console in the navigation pane and choose Stack. Okay. So by the end of the lab, you will have created the additional architecture shown in the following diagram. The table after the diagram provides a detailed explanation of the architecture, how it relates to the stack that you will complete in this lab. So here is the architecture right here. Okay. Okay, so task one is you will create and use an AWS Glue crawler named Weather, and with the Glue Lab IAM role to access the GHCND dataset, which is an S3 bucket in another AWS account. The crawler will populate the weather data database in the AWS Glue data catalog. Step two, you will also use the Glue console to transform the database by modifying its schema. Next, when the data catalog is ready, you will use Athena to create the database and build tables. The result of the queries that you run will be stored in the data science buckets, 3 buckets. You will create an AWS Glue database table using another query that only includes data since 1950, and then store the results of the query in the Glue 1950 buckets as 3 buckets. You will create views and use these to calculate the average temperature of each year. You will use the AWS CLI within the AWS Cloud 9 terminal to create the CloudFormation template. The template will create the crawler SCF and crawler weather. All the team members and other university departments will be able to use the template to create the crawler as needed. You will review the policy for data scientists IAM policy to understand the team access to the workflow. You will test Mary's access to the CFN crawler weather crawler and run it by using her credentials. Okay, so that's the introductions. Now let's go straight to the next task. So for task one, using an AWS Glue crawler with the GHCND datasets. As a data engineer or analyst, you might not always show the schema. You might not always know the schema of the data that you need to analyze. So AWS Glue is designed for this situation. You can direct AWS Glue to data that is stored on AWS, and the service will discover your data. AWS Glue will then store the associated database metadata, for example, the table definition and schema in the AWS Glue data catalog. You accomplish this by creating a crawler which inspects the data source and infer a schema based on the data. In this task, you will work with data that is publicly available in an S3 bucket to do the following. Configure and create an AWS Glue crawler. Configure and create the AWS Glue crawler. Run the crawler to extract, transform, and load data into the AWS Glue database. Review the metadata of a table that the crawler created. Edit the schema of the table. First, you will configure and create a crawler to discover the schema for the GHCND dataset and extract the data from it. Now configure and create the AWS Glue crawler. In the AWS Management Console, in the search box next to service, we're going to search for and choose AWS Glue to open the AWS Glue consoles. So we're going to find AWS Glue in here and then click it. So in the navigation pane under the databases, we're going to choose tables. Let's see right here we don't see any tables yet. So choose add table using this color. So add table using color right here, and then for the name we're going to choose weather, and expand the tag options. All right. Then notice that this is where you add tags for extra security configurations. Keep the default setting. Choose next at the bottom of the page. All right. Let's see. Expand the sections and then choose next at the bottom. We're going to add a new tag. It is tell us to add a new tag, so just choose next. Remove the tag. Okay. So now we're going to choose add a data source and configure the following. Add a data source right here, and then for data source we'll choose S3. It's already the default. For the location of S3 data, we will choose in a different account. Whereas location of S3 data is going to be in a different account. So for the S path, enter the following S3 buckets locations for the publicly available data set. So that will be that one right here. Okay. So subsequent crawler runs. Let's see, subsequent crawler runs. We're going to choose crawl all subfolders. Crawl all subfolders already selected. We're going to choose add an S3 data source. Okay. Then we're going to choose next. For existing IAM row, we're going to choose Glue Lab. Existing IAM row, we choose Glue Lab. This row has provided in the lab environment for you. For reference, use the lab cloud formation template. The following is the YAML snippet for this row right here. Okay. So what we are going to do is we are going to choose next. After that, in the output configuration section, choose add database. Output configuration section, we're going to choose add database right here. Okay. A new browser opens. For the name, we're going to choose weather data. Then choose create database. Now return to the browser tab that is open to set output and schedule praise in AWS Glue consoles. This is AWS Glue consoles, output and scheduling. For the target database, choose weather data. Target database. I have to refresh it. We'll choose weather data right here. Database that you just created. So tip is to refresh the list of available database. So we just did that. In the crawler schedules sections, crawler schedule sections for frequencies, keep the default on demand. Let's see, crawler schedules, frequencies keep on the default on demand. Then we're going to choose next. Okay. Confirm your crawler configuration is similar to the following right here. Review and create. Whether S3 is crawl all. Yep, it's look the same. Yep, it's look good. So now we're going to choose create crawler. Awesome. To perform the extract and load steps of the ETL process, you will now run the crawler. You can create AWS Glue crawler to either run on demand or on a set schedules. Because you created your crawler to run on demand, you must run the crawler to build the database and generate the metadata. So run the crawler. On the crawler page, select weather. Crawler page, where's the crawler? Right here, here's the crawler. Go inside the crawler. We want to select weather crawler. Crawler right here, selected. Choose run. Okay, a 10 minutes to start to run. So the crawl state changes to running. Awesome, it is. important. So wait for the status code to change to ready before moving to the next step. This will take about 2 minutes. The AWS Glue creates a table to store metadata about the GHC and the dataset. Next, you will inspect the data that AWS Glue capture about the data source. Now we want to review the metadata in the AWS Glue created. In the navigation pane, we want to choose the database. So this is running. In the navigation pane, we're going to choose database. Okay. I will open it as a new tab. So we're going to choose the link for the weather data database. It is in here. In the table section, choose by year link. Table sections. I guess there's no table yet because this thing is still running. They said it take about 2 minutes for it to complete run and ready. So we just have to wait for it. But then in the table section, we will choose by year link and review the metadata that the weather crawler capture as shown in the following screenshot. The schema lists the column that the crawler discovered in the imported datasets right here. Okay. Refresh that. Refresh. Refresh. It says stopping. Interesting. I want to refresh this. Okay, so here it is by year. Now go in here. Now we have the data already. Awesome. So now you will edit the schema for the database, which is part of the transforming data in the ETL process. So edit the schema. From the action menu in the upper right corner of the page, to edit schema. So we're going to edit schema. Alright. Change the column name according to the following table. So to change a column name, select the checkbox for the item that you want to modify and then choose edit. In the window that opens, change the value for the name and then choose edit. Repeat this step for each column name. So note right here that AWS Glue support column names in lowercase only. So this is what we need to change. So for ID, let's see. We change one by one or what? Let's see. Select the checkbox for the item that you want to modify and then choose edit. What I actually want to change all of them at the same time. Let's see if I have that options. Edit. Nope. That's not options. So edit schema again. Choose one, only one, and then we edit that. I see. We can change the name. The first one, ID to station. Save it. Awesome. The next one, wow, we have to manually change one by one. This one, we're going to change the date. The column to change the date. The third one is going to be type. Alright. What about the fourth one? The fourth one is going to be data value turned into observations. Observations. Next one's M flag is going to change to M flag. Alrighty. What about the Q flag? The Q flag is going to change to Q flag without an underscore. Alrighty. Move to the next one, the S flag. Change to the S flag with no underscore. Okay. Finally, the last one. We're going to change this to time. Save it. Good. Now choose update schema. Say as a new table version. That's the only option right here. There's no choose update schema. So let's save as a new table version. Okay. And choose update schema. Update schema. Where is update schema? edit table, edit schema. There's no option for update schema. Maybe go to schema and no, by year, edit schema. I bet that's just what that is, update schema by adding that. So the schema for the table now look like something on the following right here, which is true right here. So task 1 summary. In this task, you use the console to create a crawler in the AWS Glue. You directed the crawler to data that is stored in an S2 bucket, and the crawler discovered the data. Then the crawler store the associated metadata, the table definition and schema in the data catalog. By using the crawler in AWS Glue, you can inspect a data source and infer its schema. The team can now use crawlers to inspect data sources quickly and reduce the manual steps to create the database schemas from data source in Amazon S3. You share the results of this POC with Mary, and she is happy with the new functionality. Next, she wants to be able to do more analysis on the data in the AWS Glue data catalog. Now, task 2 is creating a table by using Athena. Now that you created the data catalog, you can use the metadata to create the data even further by using Athena. In this task, you will complete the following steps. Configure an S2 bucket to store Athena. Query result, preview the database table in Athena. Create a table for the data after 1950. Run a query on the selected data. Configure an S3 bucket to store Athena query result. In the navigation pane under databases, choose tables. Okay, and then we want to choose the link by year table, and then we want to choose actions, view data. Right here, proceed. All right. So when the pop-up appears to warn you that you will be taken to the Athena console, so we want to choose proceed, which we just did. The Athena console opens. Notice the error message that indicates that an output location was not provided. Before you run a query in Athena, you need to specify an S2 bucket to hold a query result. So we're going to choose the setting lab. Choose the setting tab in here, and then we're going to choose manage. To the right of the location of query result, choose browse S3. Location of query result, choose browse S3, and then choose the bucket name that is similar to the following: data science bucket. This is only data science buckets. And then important, don't choose the bucket name that contains glue 1950 bucket. I see. Then we want to choose. Oh, browse again. Data science bucket, choose. Awesome. And then keep the default setting for the other options and choose save. Very good. Saved. Now preview a table in Athena. Choose the editor tab. Okay. In the data panel on the left, notice that the data source is AWS data catalog right here. For database, choose weather data, which is already selected by default. In the table sections, choose the ellipse 3-dot icon for the by year table sections. Alright. And then choose preview table. Alright. This is our table. Tips to view the column names and their data types in this table. Choose the icon to the left of the table name. The first 10 seconds from the weather data table display, similar to the following screenshot. Yes. So notice the runtime and the amount of data that was scanned for the query. As you develop more complex application, it is important to minimize resources consumptions by optimize cost. to optimize costs. You will see examples of how to optimize costs for Athena queries later in this task. In the next step, you will create an AWS Glue database table that only includes data since 1950. To optimize your use of Athena, you will store data in the Apache's Packet format. Apache's Packet is an open source columnar data format that is optimized for performance and storage. Create a table for data after 1950. First, you need to retrieve the name of the bucket that was created for you to store this data. In the search box next to services, search for and choose S2E. So I'm going to open a new tab and go to S2E service. Okay. We're in S2E. So in the bucket list, copy the bucket name that contains Glue 1950 buckets to a text editor of your choice. Alright, so I will do a bucket for bucket list and go in here and choose the name. Copy the bucket name that contains the Glue 1950 buckets. So back to bucket. This is the name of the bucket. And what I'm going to do is I'm going to open a text editor. I want to use Note for this case. Open a new one and paste it here. Awesome. So this is what I'm going to do. I'm going to return the Athena query editor. This is our Athena query editor. Go back. So copy and paste the following query into the query tab in the editor, and we're going to replace the Glue 1950 buckets with the name of the bucket that we just recorded. Okay. So let's start doing this. I'm going to copy this inside Athena. Let's see. Okay. And then we're going to grab the name of the bucket, paste it in here. Awesome. Then now we're going to choose run. Run it. Run into query. After a query run, the runtime and data scan values are similar to the following right here. This is runtime, query data scan. It is still running on my end. So to review the result in the table sections, to the right of the late 20 table, choose the ellipsis icon and then choose preview table. Okay, successful. I'm going to preview the table. Okay. So this is what we have, similar to that. Awesome. Now that you have isolated the data that you are interested in, and you can write queries for further analysis, run a query on the new table. First, create a view that only includes the maximum temperatures reading or Tmax values. Run the following query in the new query tab. Alright. Open a new query tabs, and then we're going to run this query. Okay. Successful. Now we have Tmax. We're going to preview this as well. And this is what we have. So to preview the results, go into view sections. On the right of Tmax view, choose the ellipsis icon and then choose the preview view. The results are similar to the following screenshot. And then run the following query into new tabs. So run this. Okay, so this is what we have. So the purpose of this query is to calculate the maximum temperature of this year in this dataset. After the query is run, the runtime and data scan values are similar to the following down here. Alright, that's what we have. The result displays the average maximum temperature for each year from 1950 to 2015. The following screenshots display the following example right here. So remember that when you create queries with Athena, the result of the query must be stored back in an Amazon S3. In a previous step, you specify the location in Amazon S3 where your queries are stored. When using AWS services, you generally pay for what you use. However, because you reduce your query to only 3 columns of temperatures data from 1950 to 2015, you reduce your cost for storage. Also, because you arrange the query data in columnar format with Apache's Packet, the time that it took to perform the queries in this task was reduced, resulting in less cost as you use fewer computational resources in Athena. You show Mary that she can speed up her process by using AWS Glue in combination with Athena and still use views. She is delighted. So task 2 summary. In this task, you learn how to use Athena to create tables in the database that an AWS Glue crawler created. You built a table for all data after 1950 from the original datasets. You used the Apache's Packet format to optimize your Athena queries, which reduced the time that it took to complete each query, resulting in less cost. After isolating this data, you created a view that calculated the average maximum temperatures for each year. AWS Glue integrates with original datasets stored in Amazon S3. AWS Glue can create a crawler to ingest the original datasets into a database that infer the appropriate schema. Then you can quickly shift to Athena to develop queries and better understand your data. This integration reduces the time that it takes to derive insight from your data and apply these insights to make better decisions. Now, task 3, create a CloudFormation template for an AWS Glue crawler. In task 1, you created consoles to create a AWS Glue crawler to inspect the data source and infer a schema. However, the team worked with many datasets in different AWS accounts, including development, test, and productions. Therefore, it would be helpful to reuse crawler across these environments, especially when new data is added to the datasets. It would be also helpful to use AWS CLI to run the crawler. If your crawler runs more than once, perhaps on a schedule, it looks for new or changed files or table in your data store. The output of the crawler includes new tables and partitions that were found since previous runs. In this task, you will learn how to create and deploy a crawler by using CloudFormations. Find the Amazon resources number ARN for the Glue Lab IAM role. You need this ARN to deploy the CloudFormation template. So in the search box next to services, we want to search for and choose IAM and open it. So I'm going to open a new tab and find the IAM services. Click it. So now in the navigation pane, we're going to choose rows right here, and then choose the link for the Glue Lab row. Let's search for Glue Lab. So this is the one. Tip: you can search for the row if needed, so the ARN is displayed on the page in the summary sections. So what we're going to do now is we're going to copy the ARN to a text editor to use the next step. Copy the ARN on the summary tabs right here. Awesome. So I want to save it to a text editor right here. Okay. Next, navigate to the AWS Cloud9 Integrated Development Environment IDE. In the search box next to services, we go to search for and choose Cloud9 to open the AWS Cloud9 console. So I'll open a new tab and search for Cloud9. Click it. The AWS Cloud9 environments are listed. So for the environment named Cloud9 instance, we're going to choose Open IDE. Right here, this is IDE. We are going to open it. A new browser tab opens and displays the AWS Cloud9 IDE. Now we're going to create a new CloudFormation template. So in the AWS Cloud9 IDE, we're going to choose file and then go to new file, and then save the empty file as this glue crawler.cf.yaml to keep it open. So go to file, new file. Right, go to file, new file, and save this as empty. And now we want to save it and change the name to glue crawler. Awesome. Now we're going to copy and paste up the following code into the file right here. So copy this code and paste it into the new file and save it. Okay. So what we're going to do is note this code book use the sample AWS CloudFormation templates for an AWS Glue crawler for Amazon S3 from the AWS CloudFormation for AWS Glue in the AWS Glue developer guide. In the file, we're going to replace Glue Lab row ARN with the ARN for the Glue Lab IAM row. So look for the line that starts with row, which is around line 27. Right here, 27. Around 27. So it's right here, right? So this is what we need to look for. Oh, no, right here. Let's go back. So this is right here. So we're going to grab the actual ARN, resources name or number, right in here. Awesome. Does it have to be a string? Now let's see. Nope. We just replace it. Looking for start row. Okay, save the change to template 5. Okay, it still have to be a string, so we just save it literally like this. Awesome. Just want to make sure. Now examine the code to see what is being created in this CloudFormation template. There's the following. It set a custom resource name for the AWS Glue crawler. It set a custom resource name for the AWS Glue database. It set a custom resource name for the first table in the AWS Glue database. Create a crawler to crawl together data on a public S3 bucket. Set the IAM row Glue lab that the crawler will use to create the associated AWS Glue database. This is the same row that you use to create the crawler manually. Note that this IAM row was created for you in the lab environment. The row has all the permissions that are necessary to create and run the crawler and create the database. So to validate the CloudFormation template, run the following command right here. Okay, so we get back an object. Note, if you receive an error that say YAML is not well formed, check the value is the name of the Glue lab row. Also check the tab and spacings of each line. YAML documents require exact spacings, and this parser will encounter errors if the spacing doesn't match. So if the template is validated, the following output is going to display. So this is what we have. Okay. Important, don't go to the next step until the template is validated. Now you will use the template to create the CloudFormation stack, a stack to implement and manages the group of resources that are outlined in the template. With a stack, you can manage the states and dependencies of those resources together. Think of a CloudFormation template as a blueprint. Then the stack is the actual instance of the template that is registered in the AWS and actually creates the resources. To create the AWS stack, run the following command right here. Okay, so this is what we get back, the stack ID. Note that the command includes the capabilities parameter with the capability name IAM capability. This is because you are creating the following resources with custom names with affect permissions. An AWS Glue crawler named CFN crawler weather, an AWS Glue database named CFN database weather, a table name CNM sample one weather within the AWS Glue database. If the stack is validated, the CloudFormation ARN display in the output similar to the following right here. So this is our stack ID. The CloudFormation creates stack command creates the stack and deploys. If validation passes and nothing, if validations passes and nothing causes the stack creation to roll back, proceed to the next step. Tips is to check the progress. Tip is to check the progress of stack creations. Navigate to the CloudFormation consoles in the navigation pane. Choose stack. Okay. It's already verified right here, so there's no need to do that. So to verify that the AWS database was created in the stack, we're going to run the following command right here. Okay, so this we get back the database list. Awesome. So the output is similar to the following right here, what it did. Verify that the crawler was created in the stack. So to verify that the crawler was created, we're going to run this following command right here. Let's exit that. Run the command. Yes, we get the crawler right here, which is weather and CFN crawler weather. This is what we get as the output. So to retrieve the data of the crawlers, we're going to run the following command right here. And we got back our crawlers. So the output is similar to the following right here, which we did. So review the response. Notice that the state of the crawler is ready. This means that the crawler is deployed, but it hasn't run yet. You will use Mary's IAM user to run the crawler later in this lab. So summary task 3. In this task, you learn how to integrate an AWS Glue crawler into a CloudFormation template. You also learn how to use the AWS CLI within the AWS Cloud9 terminal to validate and deploy the template to create the crawler. With the template, you can reuse the crawler in other AWS accounts. Then you learn how to confirm that the resources were built with the crawler, the AWS Glue database, and its associated tables. Many companies use multiple accounts with AWS to maintain separate deployment, testing, and production environments. Isolating these environments helps to ensure that teams follow best practices. Building crawlers in a development account and then testing them in a control account with production data can help to ensure that the the crawler is designed as intended and extract, transform, and load the data that is intended for a specific business task. After validating the crawler, you can use DevOps best practices with CloudFormation to quickly move it to productions so that the appropriate business stakeholders can reuse the crawler without having to build from the beginning. So for task 4, reviewing the IAM policies for Athena and AWS Glue access. Now that you have created the crawler by using CloudFormation, review the IAM policies for the crawler to ensure that others can use it in productions. Note the IAM policies for the crawler was created for you. You don't have the ability to create IAM policies in the lab environment. Review the policy for data scientist policies in IAM. So in the search box to the right of services, search for and choose IAM to open the IAM consoles. So go back to the IAM consoles, which is in here. Then we're going to choose navigation pane and choose users. And here we have 2 users. Note that Mary is one of the IAM users that is listed. This user is part of the data science group IAM group. Choose the link for the data science group IAM. Let's see. Data science group, IAM group. So I guess we go to group, data science group right here. All right. So on the data science group detail page, choose permission tab. Okay. So in the list of policies, right, we'll choose permission tab. Then in the list of policies that are attached to the group, choose the link for policies for data scientist policies. All right, selected. The policies for data scientist details page opens. Review the permissions that are associated with these policies. Notice that the permission provide limited access to only the Athena, AWS Glue, and Amazon S3 services. So we're going to see right here the permissions. Yes, the permissions allow Athena, Glue, and S3 only. Tips to look more closely at the details of the IAM policies, choose the JSONs. In the JSON policies 5, you can see the allow and deny actions, including which resources the user can perform actions on. So we're going to choose JSONs right here, and it shows right here the actions of the resources, where it's coming from and stuff, and different actions right here. Just have more in depth of what is actually going on. Okay. So task 4 summary. In this task, you review the IAM policies for the data science group. The policy contains permissions for limited access to Amazon S3, AWS Glue, and Athena. The policy could be used as an example policies for users who intended to reuse crawler built by the operations team. As with our services in AWS, IAM users must have the appropriate permissions applied to be able to perform actions. For task 5, confirming that the Mary can access and use AWS Glue crawler. So now that you have reviewed the IAM policy, you will use it to test another user access to the AWS Glue crawler. You will also test the user ability to use the crawler to extract, transforms, and load data from a dataset stored in Amazon S3 into AWS Glue database. Retrieve the credentials for the Mary IAM user and store these as BAST variables. So in the search box next to services, we're going to look for CloudFormation. I believe it's already open. CloudFormation. Let's see. Nope, that's Glue S3. We don't have CloudFormation on yet, so I'm going to open a new tab right here, and I'm going to select CloudFormation, and then in the navigation pane we're going to choose stack right here, or default. So choose the link for the stack that created of the lab environment. Stack name includes a random string of letters and numbers, and the stack should have the oldest creation time. Let's see which one have the oldest creation time. It's this one right here, Glue crawlers. So I will select that. All right. So on the stack detail page, choose output tab. So go in here, we're going to choose the output tab, which is that one right here. Note that when you create a CloudFormation template, you can choose to output information about the resources that the template will create. The CloudFormation template that created the resources in your lab environment output the access key and secret access key for the Mary user. So copy the value of Mary access key to your clipboard. Let's find Mary access key in here. There's nothing in here. What about this one? So this one have Mary access key right here. This is Mary access key. So I'm to copy this, and then I want to save it into my editor. Now return to the AWS Cloud terminal. Go back to our cloud. All right. And then to create the variable access key, we're going to run the following command right here and replace the access key with the actual access key. All right, so this is our access key. Paste in here, run it. Awesome. Return to CloudFormation console and copy the value of Mary's secret access key. Let's go back to find Mary's secret access key. This is Mary's secret access key right here. All right. So go back to terminal. So return it. Return to AWS Cloud terminal. Copy after we copy the Mary secret access key. Go to the terminal, and to create the variable for the secret access key, we're going to run the following command right here. SAK. So SAK is going to equal to this secret access key. All right. To test whether that Mary user can perform a specific command, you can pass the user credentials as bash variables AK and SAK with the command. The API will then try to perform that command as the specific user. So to test the access of the AWS Glue crawler, we are going to test whether a Mary user can perform the list crawlers command by running the following command right here. We run it, so here it is. It's working. Return an object for us with two crawlers and weather and CFN crawler weather. So this is what we get as an output. So to test whether the Mary user can perform the get crawler commands, we're going to run the following commands right here, and it successfully give us back the information. So the output is similar to the following and look like the output that was displayed after you ran the command earlier. Note that the state of the crawler is ready, but no status information is displayed. This is because the crawler hasn't run yet. Okay. So tested Mary user can run the crawler by running the following command right here. Okay. Run it. All right. So if the crawler runs successfully, the terminal doesn't display any outputs. So to observe the crawler running and add data to the table, we go to navigate to the Glue consoles. Where is our Glue console? Right here. Let's go to the Glue, and then go to crawlers. There's crawlers in here. This is our crawlers. Here you have to see status information for the crawlers. It shows in the following screenshots right here. Yes, it is running. When the status changes to ready, the crawler is finished running, and it might take a few minutes. So return to the AWS Cloud terminal. To confirm that the crawler is finished running, we're going to run this following command right here. Since it is still running. Let's still check it. It's not finished yet, but oh, it still give us something back. That's good. So the output is similar to following right here, which is did. Okay, so notice the last cross section is included, and the status that in that section is succeeded. This means that Mary was able to run the crawler successfully. Okay. Let's just move this up a little bit. Okay. We go back. This is still running. So some task 5 summary. This result confirmed that Mary has access to the AWS Glue crawler that you created and deployed with the CloudFormation. This is because the permission in the IAM policies allow her to list, get, and retrieve the metadata for the crawler. Other permissions associated with the policies include the following. For AWS Glue, list, read, and tag resources. Run a crawler deployed with CloudFormation, but not create or remove resources or manage. For Athena, list, read, and tag resources, but not create or remove specific resources. For example, this policies does not provide permissions to create or remove a name, query, or data catalog, which your user has permission to do. For Amazon S3, access buckets, list bucket content, and read object, but not create a bucket and limit access to specific bucket, like the data science bucket we created for you. So congratulations, you have learned how to create an AWS Glue crawler manually by using a CloudFormation so that you can deploy it to users with a secure IAM policies. Because the crawlers is in the CloudFormation template, you can reuse the template to create deploy the crawler in any AWS account and change the parameters as desired. So updates from the team. The team is happy with that you have learned and demonstrated by using the Athena, AWS Glue, and CloudFormations. Now that you have shared what you have learned, the team will be able to simplify their workload and use AWS in a way that follow best practices. And that is it for this lab. Thank you so much for watching and have a great day. Bye bye.